too sorry to say that I just started the lesson today for a bit late because I've just finished busying preparation for the DSC exam. The teachers, they are now having the briefing, and I would like to have a lesson with all of you here. And to the best, if I can manage to finish by 10 a.m., I'm sure you can take a try on the listening. I try to get familiarized of what is happening in the DSE English exam, right? The listening exam. So after the lesson, you may turn to Outer HK radio so you know it. Okay, so this is what I would like to remind all of you. Now, today, we would like to proceed to the following part is on the consolidation. Okay, consolidation of rusting. So 2 days ago, we finished extraction of metals, reactivity of metals, and here comes the rusting. And you may find that rusting, this topic, we will have a it will give you a this one that you have some frequently asked questions, right, in this topic when you compare with the other two. While you will think of reactive metals, it will be always fused with red dots, right? Do you know that? So this is what I would like to talk to all of you here. So today, first of all, let's have a warm up to try out those social reason type questions again, and try to get to know more about the concept behind. So mainly essential factors of rusting, factors speeding up or slowing down the rusting, compare the corrosion between iron and aluminium. And lastly is to talk about how can we improve the corrosion resistance of aluminium is by anodization. Okay, so this is what I just stopped at it yesterday. So today, let's start. How about question 40? Each one of you, where we have got the questions up to 58. Okay, we have got enough person here. Make sure that each one of you would be answered the question once. The first one, I would like to invite Lei Long, Zhou Gaming, they will be the next one. Wu Gaoyan, this is 42. Now, take a look. Lei Long. Yes, take a look. Take a look. A, B, C, or D. So it is a session division type question. You judge whether or not the statement is true or false on the first statement and second statement. The steel gear system of a bicycle can be protected from rusting by painting. Painting prevents both oxygen and water from reaching the steel. You think it is A, is it? Is A. So what is painting? So what is painting? Painting means we have got a surface here, and you apply some ink, some paint on it. Okay, some paint on it, and then let it dry. Okay, so this is not painting. So it's not painting because what is meant by steel gear of the bicycle? So we have got the bicycle here, right? We have got a bicycle. We've got a wheel here, and where is the steel gear? It is somewhere here, right? The moving parts. Okay, the moving parts. So if you are going to prevent the moving part from rusting, you cannot use painting. Why not? What will happen to the paint if yes, they will stretch away. They will be peeled off so easily because this is moving. So we have got a friction between those moving parts. So they will torn apart those paints. So how would you deal with the problem of rusting? You still need to do some prevention method. Yes, greasing. Yes, that's right. You're greasing. So what is meant by greasing? You know anything about WD-40, right? This is one of the example of applying greasing. So that's why at home you may use besides having a moving part of a bicycle, you apply greasing. Yes, WD-40. Yes, that's right. You may take a look at the moving part of the doorknob, right? The doorknob over there. If you find the knob you have got it is producing some strange noise. You may find that the door cannot be opened or closed so easily. You may apply grease to it. Okay, so the similar principle. So what is the chemical principle behind? It is very similar to painting. Okay, it is to act as a protective coating. Okay, painting is just one of the example, greasing is another example. But remember, the item to be applied on is much different. Do you understand? So this is question 40. Thank you. About Zhu Gaming, question 41, your turn. And Manhei, you should be responsible for the next question. This is 43. Question 41. A. Aluminum window frames can be protected from corrosion by impressed current cathodic protection. You just put a tick here, right? And using the method, electrons are supplied to the window frames to prevent the formation of aluminum ions. Okay. Zhu Gaming, have you? How about at your flat? Do you have any aluminum window frames? If so, could you please go there and check where the current cathodic protection be found? Maybe somebody who are having the seats near the windows in a classroom, right? You know that we have got a aluminum window frames. Anyone who can tell me the place where you may find the cathodic impressed current cathodic protection? Hi, Zhu Gaming. Where? How about the others? How about the others, Will? Now, first of all, judgment or statement, correct or not? Silence. Luan Siwei, what do you think? Seems dangerous. So what is mean by seems dangerous? Samson. Dangerous in view of what? In terms of what? You mean electric shock? Well, first of all, is this method currently used? First of all, I try to take a look on the facts first, and before you talk about whether it is dangerous. Is it? So what is the corrosion prevention method of using window of having the window frames? Do you know? Paint. Take a look on the question. Aluminium window frame. So can you will have a paint on it. So what is the color of the window aluminum window frames? Normal aluminum window frames. What is that? First of all, the first statement is not correct. Okay, the first statement is not correct. But the second question is a little bit tricky when using this method. So which means that this method will not be used. But if you insist on using this method, what will happen? Can you get my point? So now take a look on that. You may think it is C. First of all, the first statement is not correct because for the aluminum window frames, it's not using this method. I use what? Anodization. Okay, use anodization. So what is mean by anodization? Anyone who still remember what's that? Thickening of, yes, thickening of the aluminum oxide layer on a piece of aluminum. By how? Anodizing. So what is mean by anodization? So we have got what? We have got a container having dilute sulfuric acid. We have got two pieces of material. Okay, both they are just aluminum sheets, and connected to what? Connected to, yes, the power supply. So what is mean by anodization? So this is the one, right? So if I'm going to have this aluminum sheets, I want to increase the thickness of the oxide layer. Okay, I put this as an anode. Anode, which means what? The electrode attracts anion. Anion is something negative. So they are now referring to positive electrode. And I put it inside dilute sulfuric acid. Do you remember that? Forgot? Anyone who still remember what is that? Put a tick. How about the others? If not, put across. Is it for improving the or in enhancing the thickness of the oxide layer? Forgot. Forgot. So anodize, which means you are going to put it into as an anode. So this is the one. Right? This is the one, anodization. Do you know what's that? I try to put a electrolyte here, and I try to put a apply some uh, electrolyte here by having this complex reaction. So finally, I would improve the oxide layer. Okay. So the whole process is to improve the corrosion resistance of aluminium. So I would expect you guys to have a, do you know what is the purpose of anodization? What is the purpose? First of all, improve corrosion resistance. What is the second? It's for improving dyeing process. Okay, dyeing, which means coloring. You may have some in the past, right? Nowadays, you usually use the plastic phone case, right? But you may have some you may have experienced some other metallic casing. One type of metallic casing is not just titanium; it can be aluminum, right? So the aluminum, they will have all got different color on it, but it's not paint on it. It's not by painting. It's by anodization after, and then later on dyeing. So it is the purpose of having this. Anyone who have also have a experience of buying some bottle milk, bottle milk. You get what I mean? So if you have got a bottle milk, we have got a cap, right? We have got a cap. We have got two types of cap. It depends on the container. One type of it is by using plastic bottle. Well, of course, the cap is plastic. But how about this one? Can you see that? How about this one? That glass bottled milk. Well, the cap here. So you may find the cap here is something metal. So you may have got different colors. So it may be blue, or maybe red, or maybe green, etc. Right? So those cap, this is just anodized aluminum. You know it. Now it's time to talk something more, but to get more the knowledge, common knowledge, right, of using metals in our daily life. Questions? So, first statement is not correct. Second statement, when using this method, electrons are supplied to window frames to prevent formation of aluminum ions. Is it a tick? Still coming. Do you think it's a tick? How about the others? It is rather debatable. Why do I say so? To me, my choice is cross. It's still a cross. Why? Wait a minute. The method means cathodic protection, which means by cathodic. Now you know that is anode, right? The positive electrode is anode. The cathode means negative. So negative electrode, which means I connected to somewhere to supply electrons. So that's why it is cathodic protection. Can you get my point? So what? First of all, you know, do you know the purpose or maybe the area, right, of application of applying cathodic protection, impressed current cathodic protection? Do you know? No idea. The car body, do you know it? The car body of it, I would use impressed current cathodic protection. Do you understand? Car body. Here, can you see that? Right? The exterior, the outside part of the car, they are just metal. Okay, so anyway, they would be and mainly some of them is iron containing, and finally they will be corroded while you place for long. For example, to the air, right? You may find that air contains oxygen, and carbon dioxide, or even on the road there are so many other acidic gases. So the prolonged exposure to the car parts, the external parts to the environment will corrode the metal part. So that's why for the car body, it's not just by improving appearance, right? It's by make the car more durable, is to apply the paint on it. You know it. And later on, for the car body here, so they would also have a very small battery that will they will put it into a cathode and will continuously supply electrons to the car body, such that it will improve it will prevent the iron inside from rusting. Do you know it? No idea. Now the question comes, just like what Samson has been worrying. So he just suggested that there may be some electric shock. So don't worry too much about that, because for a whether or not you have got electric shock depends on what? Depends on the current that may flow through your body. Suppose you have got a battery just like 2 volt, okay? You just hold even though you just maybe not 2 volt, just like dry cell, you use a finger to hold the positive and negative electrode together. Will you have an electric shock? No. Okay. You know why? Because of what? First of all, voltage is low. Second, hey, come on. Is it something about physics? No idea. What is that? Yes. Yes, the resistance of the body is very large. So which means that the current flowing through you is very, very low. Okay? So low that you cannot feel. Or even know, because of a too large resistance of your body when you compare with the voltage. Understand? So this is what I would like to talk to you, all of you. This is the way to improve the rusting of the car body parts. So go back to the question. For the aluminum window frames, we will not use this method. But even though I use this method, I apply the same concept. Why do Mr. Chin disagree with this statement? Anyone who have a try? Can you get my point? Why? Now remember, if I give you some hint, if the metal is iron, I will say yes. If the metal is aluminium, I will say no. Is it a good hint? Anyone who have got the idea in mind? What I'm now referring to? Yes, that's right. What happened to the corroded product? But not the term permeable. What is the core part of? Yes, yes, that's right. Can you get a point? So upon the oxidation, right? For if I have got a piece of aluminium, no, even though we do not have any anodization process, right? We have got a very thin layer of the of aluminum oxide, which covers the surface, right, of the aluminium. And this one is a very tough layer, which is impermeable to the incoming of oxygen and water, uh, such that the aluminum underneath will no longer be corroded. So we are now dealing with this piece of window frame, okay, or aluminum first of all. Aluminum window frame is we have got a thicker oxide layer artificially, right? And what's next? If I put electrons to it, no other reactions. Can you get a point? So the answer is no. Answer is D. Question 42. When iron is immersed in a hexane, can you see that? What's the next one? Who is the next one to answer this? Wugalum. When the one you may find it into the contact list, right? The participant list, please find a place such that you can answer those questions. When iron is immersed in hexane, iron rusts rapidly. No. The answer is no. All solvent can speed up the rusting of process. The answer is no. D. Okay. So what's the point? What's mean by solvent? So what solvent will speed up the rusting and will make the rusting process going quickly? It depends on what. You go back to what? Yes. you go back to the essential factor of rusting. So I need what? Oxygen and water. So if you talk about solvent, generally speaking, we are now looking for the solvent must be of water. Okay, we should be with water inside. So hexane, it is immiscible with water. So of course, you may find that it's non-aqueous solvent, right? It's a very good hint already, non-aqueous solvent. But of course, in your DS exam, I'm sure this one will be deleted, right? A testing of hexane. And ask you guys if you know what is hexane. What is the physical property of hexane? Question 43. Seaside environment can speed up the rusting process of iron and steel. The air of seaside environment contains ionic compounds. What do you think? Next guy, 黎允證。老師話唔問希啊 you are going to follow the following questions. 黎允證 Question 43. Speed up, that is the fact. The air that contains ionic compound, it is also the text, but it is not the reason. B. So what is the reason? If the second statement is not the reason, so what is the reason? Why would have the piece of iron pulling into the seashore? Why will rust so quickly? More speedy than the normal case. Some of you think that higher humidity. Yes, I would admit that it is one of the reasons. But how about the factors of the sea vapor? The sea vapor, do you have an experience of tasting the sea vapor? Tasting. Yes. So what does it mean by that? The air inside the sea environment contains ionic compound. Right? Can you get my point? So seaside, now when compared the two places with the same humidity, okay, even though I've got inland we've got same humidity, that the seaside, the same of the sea humidity of the same humidity are the iron, the piece of iron put near the seaside, okay, will rust more quickly. And because of what? There will be some other factors that will speed up or slow down rusting. So the answer is A. 盧少華 44. During rusting, iron atoms gain electrons to form iron 2 ions. Rust indicator give a blue color in the presence of iron 2. So what's wrong with the first question? What's wrong with the first question? First statement. Yes. This one won't lose electrons. Okay, lose electrons. So the answer is C. 文希 45. Alkaline solution can speed up the rusting process of iron. Alkaline solution contains ionic substances. A. Agree? Agree? A. How about 46? Aluminium is commonly used as a sacrificial metal to prevent rusting of shield's hub. Sodium is more reactive than iron. Next guy, 温子維 C, cross intake, right? So we will not use sodium. So what is the metal to be used? Commonly used. We use zinc. Yes, zinc block. Okay, we use zinc block. And frequent replacement of zinc block. They will protect the ship house from corrosion. 47. Anodized iron is commonly used to make window frames. The corrosion resistance of iron is increased by anodization. Chen Junhei. Chen Junhei. Anakin.
兩個都錯，嗰個係 C。
兩個都錯。But your answer is C.
我唔記得咗嗰個係乜嘢。
嗯 could you please speak louder?
兩個都錯，嗰個答案係乜嘢
？All right. Have you started doing the past paper? Or you just told me already? Now, a reminder to all of you about the two choices. Okay? Don't worry. Next Friday, your quiz, right after the periodic pattern, the quiz on periodic pattern, I will give you a quiz on 36, okay? Of 36 MCs, which means part of the paper 1 questions. Okay, I give you some time on practicing the questions. And you will know that what is A, B, and C, and D. A and choice B, both statements are correct. But if you talk about the causal relationship, okay, statement 2 can explain statement 1, it is A. B is 2 irrelevant statements. Statement C, choice C, which means cross and tag. D is double cross. Or maybe just Anakin, you just wake up. So still not yet refreshed. So I do wish you could do you could have done a lot of past paper practice. 48.
Sorry.
Don't worry, but I do think I may be more worried than you. 朱俊輝 Iron nail kept in the vacuum will not rust at all is correct. Iron only cockroach rainbow. Yes, that's right. It's A. 49. 李振傑 Iron nail rust more rapidly in seawater than tap water. Iron-like substance. Yes, that's right. It is A. Cyrus 魏卓賢 Tin plated instead of galvanization is applied to iron food cans. Tin is less reactive than zinc. Yes, the first statement is a take. We use tin plating, but not galvanization, right? You know that instead of, right? The first statement is take. How about the second statement? Tin is less reactive than zinc. Yes, that's right. Zinc, iron, tin, lead. Okay. That's the answer is B. If I want to make a statement, change a statement, it is, yes, this is A. What should I do? In this zinc, ions is toxic. So what is the reason for statement 1? zinc iron is enough. So what do you mean by that? Now go back to the first question. Tin plating will be used to is applied to food iron cans, iron food cans, but not galvanization. So you just show the part of the explanation part to justify why can't we use galvanization. Is zinc iron is being toxic, right? How about tin plating? Why would we use tin plating? Can you get a point? Now you have to go back to the question. To the question is about what? Now, just like Wen Jiwei, we think that the focusing point is tin and zinc, right? Yes, this one is non-toxic, but you still need to tell me what plating. Plating. So what is the chemical principle of plating a metal in onto it? Anyone who can tell? Cyrus. What is the underlying principle of plating a metal onto another piece of metal? Cyrus. You just gone out for breakfast? You're still the one, right? You have not finished the question. You haven't finished this part. This part you should be responsible for question 50. Or when answering the questions, you suddenly did not admit you are Cyrus, right? Hey, come on. What is the chemical principle of having this metal plating to prevent rusting? How? If this Cyrus cannot manage, can I have another Cyrus to cover the surface of the food can? Finish? Your argument finished? Yes, that is the second point. I would like to have a protective coating, right? This is a chemical principle. It's simply said as protective coating. If you elaborate more, what is that? Right, the protective coating would prevent the incoming of oxygen and what? Sorry, Cyrus, if you still write it down this way, no marks, because I just see the word air. What are the essential factors of rusting? Yes, that's right, oxygen and water. Remember, Cyrus, could you please write it again to avoid what? To avoid the contact between the metal and oxygen and air. Okay, better not write it down. Oxygen and air, is it? Is it? Oxygen and water? But so which one is correct? Yes, water vapor. Oxygen and water vapor in the air. The answer is oxygen and water vapor in the air. Okay, got it? Question 51. Another Cyrus, are you here? Another Cyrus. Hi, morning. Have you had a breakfast? Question 51, please. When an iron nail wrapped with a copper wire is left in the air for a long time, the iron nail does not corrode. Copper prevents iron from rusting by sacrificial protection. Hi. First of all, do you know that you have got a chance, right, of having a class resumption shortly? You better get used to the to the mode of the lesson, huh? Both wrong. Both wrong. Why both statements are wrong? So could you please change this statement for a little bit? Now, so what's the point of having these two, iron and copper? So what is the meaning? Sacrificial protection is something related to plating. Anyone who can help? I should not be always the one to further clarify your doubts. Anyone who can help? For those who feel so comfortable, right, to speak up, I'll turn on the mic and tell. Don't worry, huh? I will invite somebody to say. So how about you? Don't just laugh at another Cyrus. You should be the one to answer, right? Sacrificial protection is used to, what is that? Is used oxide of another metal which is more reactivity. Well, what is that? Why? This time I need to give you something. Yes, that's right, Samson. This is what you just said. What about what? It is sacrificial protection, right? Sacrificial protection, which means sacrificial means some metal will be sacrificed, such that they will protect the target metal from being corroded. So what metal should be sacrificed? So the best way is to have a direct contact of the two pieces of metal together, first of all. Second, because of the difference readiness in losing electrons when it comes into contact with air. Okay, so what will happen? So what can be the combination, right? As long as we have got two pieces of different metals, they stick together, one metal will even loses electrons more readily. Okay, but than the other. Do you know why? First of all, the reaction will still continue when it come up with to the air. Now we have got metal 1, we have got metal 2, But you know that metal 1 loses electrons more readily than metal 2. So what happened to I have got two pieces of metal together. Now, first of all, the metal 1, according to the book, saying you may know that metal 1 will supply electrons to metal 2 such that metal 2, if the metal 2 is the target object, this one, they will not be oxidized so easily. Can you get a point? So what will, and finally what will happen to the metal 1? Metal 1, they will form oxide. Okay, so we will say that this one metal 1 is sacrificed. So the whole process, we call it is sacrificial protection. Do you still remember? What is that? Sacrificial protection. So the choice of that too should be metal. So most of the time for the metal object, we are going to talk about iron. Okay, can you get a point? So the for the metal, which is suitable to do the sacrificial protection, should have the reactivity higher than iron. So can you see the word? So that's why if you talk about this one, it is metal 1. You may give you some example, just like magnesium and zinc or etc. Right? Can you get a point? Can you get a point? So, for what will happen if I do not put it in magnesium and zinc, instead I put it as copper. Instead, this part, metal 1, I put it as copper, and metal 2 is iron. So what will happen? Yes, the direction of the electron flow is different. You are going to its reverse because iron this time is more reactive than copper. So for what will happen to the iron? Iron will speed up rusting instead of slow down. What does mean by speed up? Even more, it will rust even more quickly. So how come it will react more quickly? Now, because of two reasons, right? First of all, they will speed up the losing of electrons from iron to copper. Second is what? Iron is still being in contact with oxygen and air and water vapor. Here you see that oxygen and water vapor. So which means that normally iron itself will undergo rusting. Can you get a point? But if I put the piece of copper into it, it will make the rusting process even faster. Can you get my point? Because the losing of electrons, it is in two ways. Normal rusting and also the losing of electrons from iron to copper. So finally, the rusting of iron will be quicker. Do you understand? For those people who just got understand my saying, now could you please put a thumbs up? Let me know. You understand, right? So why do I say sacrificial protection in this case, but not plating? But not plating. Now plating is another concept. Plating is another concept. What is the another concept? Yes, iron is here, right? And then we have got the metal, which completely cover the surface of iron. Okay, so this is what we call that as a protective coating. So what is the choice of those coating metal? Can it be magnesium? Can it be zinc? Can it be tin? Can it be copper? Now, why do I use different examples here? Can you see that magnesium, we seldom use it. Actually, you can use it, but seldom use it. Zinc, more commonly used. Tin, more commonly used. Copper, less commonly used, actually. Now, take a look on magnesium and tin. When you compare with the reactivity of iron, zinc is more reactive, while tin is less reactive. While both also make it as a protective coating. Can you get my point? Both also make it as a protective coating. So it is the matter of reactivity series. But when you once mention The principle is protective coating. First of all, you have to check whether or not we have got a complete, okay, covering of one piece of material on the other, irrespective of their reactivity. I may say it like this way, okay? Of course, don't argue with me, just like, how about a piece of sodium metal, potassium metal? Of course, it's another way around, right? But if you want to talk about zinc or tin, like this, or even just like this case, I use copper to completely cover the surface of iron. Okay, the respective of the reactivity, it serves as a protective coating. So remember, these two principles is different. Do you understand? If you can you make a difference between the two, the one on the left hand side, the one on the right hand side? If you really understand and make a difference between the two, now could you please clap your hands? You really know what is that? Just 4, 5. You know it. Yeah, great. You know it. You know the difference, right? Good. You know the difference. So, go back to this question. If I say that an iron nail is wrapped with a copper wire, which one are we talking about? Is it a protective coating? Wrap with. Can you see the word wrap with? It is something about English, right? Yes, that's right. So which means, yes, that's right. You use the piece of iron nail with a metal strip, just wrap, but not directly cover. It's not plate. Wrap is not equal to plate. It's not the same. Do you understand? The answer is D. 52. Do you understand? You feel better? You feel better? Now, if you feel nice, I would like to continue that bird. Cross them out now. I would like to cross them this one. Now, how about the answer is D, as said before? How about 52? 52. Iron pipes, they are often connected to lead blocks. Lead can protect iron from rusting by sacrificial protection. D. Why is this first statement wrong? Iron pipes, they are connected to lead blocks. No, it's not by using lead. Why not? Yes, you use empty block, but my question is, if I put a lead block into it, is it possible? Yeah, that's right. Iron is more reactive than lead, so what will happen? Yes, the rusting will become faster. It is because the sacrifice, the metal surface sacrifice is iron, okay, instead of lead this time. The answer is D. 53. Zinc blocks, they are often attached to the steel legs of an offshore oil platform. Zinc can protect steel from corrosion. 李卓俊 李卓俊, are you here? Gone away. Third time,李卓俊. Okay, your turn. 55. You know who will be the next guy, right? We just start from Lee, right? So what will be the answer for 55A? Yes, just mentioned. Just mentioned long time ago. 10 minutes ago. 54. Next guy, Samson. Connecting the steel structure of a pier to the positive terminal of a battery can protect the steel structure from rusting. The positive terminal of battery protects steel from rusting by sacrificial protection. Yes, a very confusing term this time. Very, very confusing. Right? Because you may see so many terms, so many new terms here. Samson, what do you think? A, B, C, or D? D. What's wrong with that two statement? What's wrong? Second statement is wrong is because of a cathodic protection. How about the first statement? You're just telling me it is the first statement, right? Impressed current cathodic protection. This one. This is negative terminal. For the negative terminal, there is a places where electrons they are supplied to it. So this part, the positive terminal, of course, is not correct. But the question comes, sacrificial protection. So which means that for the first statement, I change from positive to negative. It is correct. How about the second statement? Even though this one positive terminal, I change it to negative, this statement is still wrong. Can you get my point? So what should be the answer, right? I cross them out. So what is that? It is impressed current cathodic protection. Do you understand it all? Now this statement is a very good way to test your clearness of understanding of those concepts. 55. Aluminium is an unreactive metal. Aluminium is corrosion resistant. 徐家榮，徐家榮，徐家榮 three times. Not here. If it's not here, I mark it as absent. 徐家榮 55, please. Statement 1, correct or not? Unreactive metal. This is wrong. Corrosion resistant. 徐家榮, you mark it wrong also. Agree? D。陳偉豪
係
，What do you think?
56啊，
55。
睇下先。
Your classmate suggested as D. Do you agree?
I think it's C.
C. Statement is correct. Why? Why is it correct? Have you done the corresponding essay? 陳偉豪, or you just told me here very clearly that you haven't done the essay?
Not yet.
When will you submit your work? Do you know where we are now? 20, nearly 30, right? Yes, the corrosion of aluminium is constructive. Once aluminium reacts with oxygen, so what will happen? The oxide layer, what will happen to the oxide layer? Yes, coating effect. What does mean by coating effect? Now be aware of using this term, right? Coating effect. Coating effect is something what you want or what you don't want, actually. So that's why I ask you guys to be very, very cautious when you use this term. Of course, it's the coating, but is it what we currently talk it as a coating effect? Yes, that's right. As suggested by Wan Ziwei, right? Aluminium oxide formed, which is impermeable to the contact of oxygen and water, such that the aluminium underneath will not undergo corrosion anymore. Okay, so that's why even aluminium places very high in reactivity series, we will say that it is corrosion resistant. So this is the commonly seen past paper question. So 陳偉豪, tell me when today. Good. I'm very afraid if you say that 2022 from your D's, it seems so. Is it 2022? It's 2021, right? 陳偉豪, you dare not say anything, yeah? You can get what I mean, right? Great. If you didn't reply me, I suppose you understand what I've just said to you. I don't want to make things too explicit, right? And question for 56. 粵賓，粵賓，Where are you? Reading. So while you spend time of reading this question 56, I would like to remind who will be answering the following two questions. 57, Yuan Tianyao, and 58, the last question, Yong Zhenglan. For those who are ready, you may tell your answer. Hey, come on! I may tell you an inconvenient truth, huh? Chem 1 students, even though we will have a class resumption, which will be probably half day 1, we may tend to have the morning class instead, but not afternoon, isn't it? The strength of the aluminum object can be increased by anodization is cross. During anodization, the aluminum oxide of the surface of the aluminum object is converted to aluminium. Come on. The answer is D. First, why not? First statement is not correct. Strength of the aluminum object can be increased by anodization. No, it's not strength. So can you, if you are asked to change the statement, how should we change it? That's correct. Yes, that's right. You may improve corrosion resistance. Good. Corrosion resistance can be improved, right? By anodization. How about hardness? Is it okay? The strength not correct. Corrosion resistance correct. How about hardness? Correct or not? Wang Jiwai, correct or not? Not correct. Not correct. Okay, it's not wrong. It's not. It's wrong. Okay, it's wrong. How about surface hardness? Surface hardness. Have you ever heard of this term? Wrong. Some how you say it wrong. You better search for it on the web. What is mean by surface hardness? It's different. And second statement, during anodization, aluminium oxide on the surface is not converted to aluminium. I increase what? The thickness of aluminium oxide layer. Okay. How about 57 and 58? 57, 原天油 A. Anodized aluminium is an alloy. During anodization, aluminum oxide is formed on the metal surface. This one is correct, right? The second statement is correct. How about the first one? Anodized aluminum is an alloy. No, the word alloy. Alloy is not correct. So what is mean by alloy? Alloy. All of you, please mark it down. A mixture of a metal with at least one element of another element. It is not necessary always to be metal. It can be non-metal. For example, steel is iron, carbon, okay, iron, carbon, alloy. So one more term, one more adjective I would like to stress with you is the word uniform. A uniform mixture of a metal with another element is a steel. So anodized aluminum, I try to improve the thickness of the oxide layer onto the surface of the aluminum. It's not alloy. Alloy is another thing. Okay, alloy means the making of alloy involves the melting of the metal, with another metal or element, okay, to form a new, to form another mixture. To form a mixture, we call it alloy. You understand? So this is a cross. Take C. How about another Leo? 58. Anodized. Yes, aluminum is more commonly used than iron for making window frames. As I said before, anodized aluminum is corrosion resistant than iron. That's right. The answer is A. In the past, we used window frames making of iron, but iron will rust for a long time. After a long time, because and you may know that some iron objects is rather brittle. So how could we improve, right, the situation? How? You know it? Anyone who have seen the window frames not making of aluminum, instead this is iron. You know what's that? So how can we improve? How can we slow down the rusting of iron if I use iron as a window frame? You don't know it? Yes, that's right. Painting. Some old flats, I know that maybe some of you who are still living in very old flats without any renovation, right? The window frames, they are mainly iron window frames. So we need to apply plating onto it frequently, maybe yearly, annually. Do you understand? A very fruitful lesson, isn't it? What do you think about having the recession type questions for such a long time, while Mr. Chin spends nearly 1.5 hour with you on this? Do you know why? Do you know why I insist of asking each of you to think it very, very carefully on this topic? Do you know? Do you know? Among those 3 chapters, if you talk about rusting, corrosion of aluminium, anodization, sacrificial protection, protective coating, something like that. All different. They were under. You need to memorize quite a lot of the chemical principle, and you need to distinguish which is which well. And which means that's why among that 3 chapters, the concept of rusting, rust prevention, etc., it seems more commonly seen in the exam. It seems it is more frequently assessed. Do you understand? It seems they are more frequently assessed. Do you understand? So last question, 2021 or 2022? Come on, students. 2021. Ready? 陳偉豪 2021 please. Just face it. If you just give me the answer not 2021, you never know what is the last digit. You just procrastinate. It's time to go back to the consolidation by yourself. Get yourself prepared for the coming quiz this Friday. Essays, missing quizzes, missing essays, spend some time on it. Okay? A fruitful lesson today. All right? That's it. Bye.